Oh, sweet. I was about to celebrate being in double digits, and I got a little deeper into double digits. All right.
I can ask for the section B in question number 7.
Let's see. Okay. So in 7A, you figured out, I don't know, did you have the one with musical instruments?
No, for people, yes, musical instruments.
All right,
Yes.
all right. Wind instruments and percussion.
Sorry.
All right, so whatever you have. In 7A, you set up a Venn diagram, correct?
Yes.
And what's 7B, the first thing asked you?
7B. If we pick one person at random, find number 1, people only play wind. I answered people only play wind, but this is wrong because
Well, P doesn't stand for people. What does P stand for? P with the parenthesis, that's the probability of. The probability of somebody only playing wind.
Okay, that's mean.
Out of 155 people, how many only play wind instruments? So probability set up a ratio, huh?
18 over 155.
Yeah, that's what it would be. Yeah.
Okay.
Yeah. I like it. So you can think of P as being probability. You can also think of P as being percentage,
Okay.
because they're basically the same thing for the most part. Okay.
Okay. Fine. Thank you.
Sure. How's everybody else? Any questions from homework or corrections or general stuff or anything? Okay. All right. If there's no questions, we're going to get back into what we were doing yesterday. Slowly transitioning, waiting to see if there's any questions coming at me out of nowhere. Nope. Okay. Do you guys remember this here? This is like the last thing I think that we did yesterday, just about, was discover this little shortcut. So let's kind of do a problem and see how this thing works. Here we go. I got some white space here. Bam. Yay. Oh shit, I didn't set this up. Hold on. Liquid. Okay. So the general form, unplug you, let me plug you in. Hold on, guys. Sorry. I got to keep all my wireless shit freaking charged up. Okay. The general form of a quadratic function is that. That is it. That's the general form. So let me ask you real quick. If I had this function, oops, I've got a chat coming in. Oh no. Okay, go ahead. Sorry, somebody private chatted me something. Can somebody identify for me what A is in this?
-7x squared.
No, careful.
Just -7.
Good. All right. Now somebody else tell me what B is.
-6.
No.
5.
5. Good. What did I do to be an asshole? Is that in order?
Switched it.
No, oh yeah, that's not in order.
So what is the definition of A? The number in front of x squared. What's the definition of B? The number in front of x. C, poor little dude all by himself. Aww. You guys okay out there? And then of course, what's C? Now come at me with C. Come at me with C. Come at me, bro.
-6.
Negative six. All right. So now, just to remind you guys, to find the vertex, which is a point, there's a shortcut we developed yesterday. And hopefully it made a little bit of sense. I don't know. I was discussing the fact that the vertex is always between the two intercepts. And we did some neat stuff. I don't know if you guys agree with me that was neat. But we came up with this shortcut. X will be negative B over 2A. That's kind of neat. So that's the X piece of the vertex. So let me give us a slightly less disgusting function here. So what if I had, what do you got, Jeff? 2x squared plus 12x minus 7. I like it. So what will the X piece of the vertex, how would I figure that out? What's A?
12.
That sound meant you were wrong.
2.
2, yeah. A again is the number in front of the x squared term. So this is in order, right? So there's no tricks here. That's in order. And you guys understand what in order means? It's in order of decreasing x's. Is that cool? 2 x's, 1 x, no x. So A is 2. What's B?
12.
Well, what's C?
At -7.
Yeah, we actually don't care what C is for this process, but we'll list them just so he doesn't feel left out. So, and again, I know I showed you yesterday, I showed you where this idea came from. As a student, it is really easy to lose the connection between why we do this and doing it. So then in your brain, you start to think math is magic bullshit that they just made up and they told me to do it. I'm going to do it. I showed you why this makes sense. Even if you forget what I showed you, remember there's a reason this makes sense. There's a reason this works. So how would I set this up? I need B. So we already know B is 12. So negative B, negative 12 over 2 times what?
2.
Yes,
2.
over 2
Yeah.
times A. 2. You guys, so it's just plugging stuff in. This is a beautiful shortcut. If you know what A and B are, you can plug them in into the shortcut and find the vertex very quickly. All right, let me be quiet for a minute. Okay. I know it wasn't a full minute. I can't do it. So then I get negative 12 divided by 4. So I get negative 3. That's the X piece. Okay, you guys with me out there? You guys hate me? That's okay. And let me do this. So I got, this is 3, negative 3, Jeff. How do I get the Y piece?
Do you plug it back in?
Yeah, anytime I have an X and I want to know the Y, I just plug it in. So now the Y piece will be G of negative 3. Uh-oh, let's see what gross thing we get here. So now you just gotta brute force that bad boy, right?
That's the Y?
Yeah.
Okay. I think I'm a
Was it
little
56?
confused.
All right, now listen. If I have, all right. Let me see. How do I say this? Are you confused because this is here?
I'm confused because that's the variable is X. So when we go to this equation down here, are you just switching the variable to Y?
No. So this is not X, is it?
It's G of X.
It's a function of X.
Yeah.
But what do I get when I put a value of X in? Don't I get the output? which we normally call Y.
Yes. Okay.
Okay,
Never.
good.
That makes sense.
So here's the thing. Here's the thing that we might be missing on function notation. All this kind of does at the very beginning, I mean, we can do a shit ton with that notation, but it just takes the place of Y.
Yeah.
Because
Okay.
it's better than Y, because I can keep track of what I'm actually plugging in.
It's the function of X.
Yeah.
That makes sense.
So the
Okay.
output, we normally call it Y. We can give it a function name, because then we can have like the revenue function, we can have the area function, we can have the profit function, just by giving us different letters and keeping track of what the inputs are. Yeah. So good question. I like it. That still is Y. We just call it something of X, just as a better notation. So let's see what we get here. 18. You could do it, Jeff. There you go, buddy. Minus 36 minus 7. And I believe that's negative 25. I don't know if you guys are with me at all now. Let's see. So I just figured out what the vertex is. Negative 3, negative 25. Let me see if I can push this a little bit. All right. Any you guys have got to let me know if something's not making sense. I kind of smushed a lot of work in here, and I'm sorry for that, but oh well.
Professor, I got a question.
Yes.
When we're finding out the Y, you see how you put after the G parentheses negative 3, you have the 2 times negative 3 squared on the bottom. It's towards the bottom.
Yep.
Yeah. How did you get the 2?
Isn't
Oh,
this the function? Yeah.
okay.
So
Okay.
how to get to 2 is there? How to get to 12? And then
The
the
B,
7.
like the B and the C. Okay, that makes sense.
Yeah. So all I did, once I know a specific value of X, negative 3, I can plug it into this to figure out the output.
Okay, you literally just put 2 and then X squared.
Yeah. I just rewrote this knowing what X is.
Okay, that makes sense. Thank you.
Like it. So stay with me now. This is kind of a gross picture, but too damn bad. Jeff, you put that in the wrong place. It'll be okay, Jeff. You'll see why. I drew that line in the wrong place. There we go. So the vertex is at negative 3. All right. Vertex is at negative 3, negative 25. Stay with me now. Stay with me now. Let's see. How can I make this better? I don't know. We'll do 4, 8, 12, 16, 20, 24, 28. This kind of sucks, Jeff. It's too bad. Oh my God. All right. Now, the vertex is at negative 3, negative 25, right? So I'm going to put it right there, negative 3, negative 25, plot. So there's the vertex. Let me put the function up here again that we're working with. Jeff. Can somebody tell me? Let's see who's remembering stuff out there. So is that okay? All I did was plot the point we found. We found the vertex is there. Does this open up or down? Up, because this is positive. If it was down, it would be negative. It would be sad, poor little thing, but it's positive. It opens up. Does anyone remember how to find the Y-intercept of something? How do you find the Y-intercept of something? What's true about X at the Y-intercept? If I have a Y-intercept, what's true about X? For any, even a curvy dude, what's true about X at the Y-intercept?
0.
0. What do you get when you put a 0 in this? When you put a 0 in for X, what do you get?
Negative 7.
Negative 7, yes.
Oh,
2 times 0 is gone, plus 12 times 0 is gone, minus 7, you get a negative 7. So the Y-intercept is 0, negative 7. So let me put that on there. So I can see this thing kind of taking shape. It's going to go like that. And there's going to be, let's see if I can get this. I don't know if you guys are going to be with me on this, but there's going to be a point there. It's symmetric. So it's going to be like a mirror image point that I missed entirely, but I won't. All right, that's not bad for me. So if we found the vertex, which in this case is the lowest point because it opens up. It's going to be like a valley. If I then find the intercept, I can actually plot the whole thing. Okay. Maybe. That was a lot. Let's do another one using this shortcut. Yes. Oh, somebody I thought was going to say.
Yeah. So for that second point, so you know how you got the one across, yeah, that one right there, that one. Yeah, how like I see you got -8, and then how did you get that?
-7.
Yeah.
So if there's a point here, doesn't there have to be a mirror image point? That's the neat thing about parabolas. They are perfectly symmetric.
Okay, so
If there's a point here, there has to be a mirror image point there. There's a point here, there has to be a mirror image point there. Isn't that neat?
okay, so that would be -7.
Yeah, this would be actually -6, -7. So like, isn't -3 in the middle?
Yeah.
So if it's 3 over to here, it's got to be 3 over to the mirror image point.
Okay. All right. Simple. All right. Thanks.
That's neat. And again, this is actually more than you guys have to do, but I just want to give you the whole idea of what we're doing. So by doing this work here, we figure out the vertex. Would you agree with me that the vertex is just about the most important point on a parabola?
Yes.
The important parabola point is vertex. Okay, so I'm going to clear all this away. You ready? This is really a mess here. Let's do another problem a little bit cleaner. I'm going to clear all this away. It is now gone. Okay. So what about if I give you this function? Let's see, let's make it a little less evil. Just a tiny bit less evil. Sure, Jeff. Okay, I like it so far. This is good. And now put something else, Jeff. Sure, okay. So we put over here this. Can you guys take a minute and figure out what the vertex is? Don't say anything out loud. So here's the formula for the x piece. Oh shit, Jeff. Trying to figure out what the vertex is. Don't say anything yet. Don't chat anything yet. I need some sleep. Jeez. All right, so somebody help me out. What is b in this function?
-8.
-8, 11. And what's a?
1.
1, 11. So understood 1 here. So then my x piece of the vertex will be 8 divided by 2. 4. What's the y piece? How do you figure out that?
Plugging 4 in for x.
Good. Put 4 in for x. So I get 4 squared minus 8 times 4 plus 4. I just can't get positive outputs. Oh, well, too bad.
-12.
-12, I love it. So that means the vertex is 4, -12. What's the, let me put this up here. What's the y-intercept? You guys see the shortcut to get the y-intercept?
4.
Well, 0, 4, I like it.
0, 4. Yeah.
It's going to be whatever c is. So C has a purpose. Poor little C. See how the vertex stuff leaves C out? And then C's like, I have a purpose. It's the y-intercept, because when you make x 0, it's the only thing that x can't kill. It's still there. X gonna give it, no, can't give it to C. And then let me think. Where am I at? Oh yeah. This is extra. I don't think that the homework is going to make you do this, but let's see if we can do this. So my vertex is at 4, -12. Jeff, can you count? Maybe. Maybe. Sure, let's do that. -4, -8. I guess I didn't need all that. So I can put the vertex right here, 4, -12. The y-intercept is at 0, 4. You guys with me? We found this over there. We found this up here. I can put those now. Where is there another point? Can somebody figure out where's one more point that I don't even have to do any work for? Isn't there
It's
a
gonna
mirror?
be 8, 8, 4.
Yeah, there's a mirror there. So it's 4 over, so then 4 over, and there's the mirror image.
8, 4, right?
Yeah. What? Gee, crap. All right, make that big. Okay. Poor little parabola was left out in the sun. Somebody sat on it.
So I have a question.
Yeah.
Okay, so if the A were to be a negative, then the point would be a let's see. So that's 4. It would be -4, and
Well, let's try it. Let's try it. Let's do your problem. Is everybody cool with this? And real quick before, so Guillermo, let's do one that opens down. Let's do exactly this one, but I'll just make the A negative, right? And we'll see what happens. But real quick, what point is this? I think somebody already said what it was. It's 8, 4. Is that right? Yes.
Yes.
Okay. What does that mean has to happen when I put an 8 into the function? What do I better get what out? If I input an 8, what should my output be? You guys, what's the
4.
point? Yes, the point says input 8, output 4. That's what the point says, correct? So how can I check to make sure that what I've done is correct? I can try to put an 8 into my function. Let's see what we get. 8 squared minus 8 times 8 plus 4. I get 64 minus 64 plus 4. That's freaking 4. Yay! I'm sorry, I'll calm down. Maybe? No? Maybe? A little bit. All right. All right. So let's try. I like this. So I'm going to erase all this. You guys ready? Here it goes. Forever gone. All right. Oh shit. What was it? Negative. So if I make this negative x squared, what was it again, guys? Was it minus 8x plus 4? Yes. Let's see what this does. Let's see what this does. So what happens to the poor little vertex dude? So x is still going to be negative b over 2a. What's b? It's still negative 8, but what's a?
-1.
Negative 1. So now this becomes 8 over negative 2 is negative 4. So that's the x piece of the vertex. To get the y piece of the vertex, I just plug that in. You see what we get. This gets a little bit weird. Are you guys cool with what's happening? I have not been cool with what has happened since the day we started, Jeff. Oh shit.
No, yeah, I'm here. I'm here. Let's see.
All right, all right. So all I did was plug the negative 4 in so I can see what the output was, so I can complete what the vertex is. So what do we get? We get negative 16. So some people get tripped up with all the negatives here. When I square this, that negative goes away, but that negative is still there. Negative 16 plus 32 plus 4. So I believe I get 20. So now my vertex is -4, 20. And what's the y-intercept still?
4.
Yeah, 0, 4. So now I want to go to graph this. Jeff, well, that's all right. You'll be all right. Will you be all right? I think so. Let's do 2, 4, 8. 2, 4, 6, 8. There you go, Jeff. I don't know if you're going to be all right, man. And then here we'll go 5, 10, 15, 20. Sure. So the vertex is at -4, 20. My y-intercept is at 0, 4. So where's there going to be a reflection point? Where's there going to be another point? This is the mirror. There's a point here. Where must there be another point?
-8 and 4.
Good. And now, of course, it opens down. Oh, shit and a half. Because of the negative, crap and a half. Why can't I draw? Oh, screw it. All right. Suffer through that. Sorry, guys. It opens down. We didn't even like apply. It just happened. You guys with me? It just happened that it was down. And this negative made it go down instead of up. Frowny face. All right. You guys okay out there? All right, now we end up not doing a ton with this, but do you understand that so many things in real life can be modeled with parabolas, and the vertex is in a very important point. It is an extreme point. It could be a point we want to avoid, like this could be the maximum power use, or it could be a point we want to get to, like max revenue or min cost. If it's a cost function, it would be like a down parabola. Okay, maybe. All right, maybe. So having a shortcut to find the vertex is remarkably useful, since so many things can be modeled with parabolas. If I can find the vertex, it's a very important point to know. All right. Let me erase all this. Here we go. Clear. It's going to go away. You guys ready? Clear. Okay. All right, let's see what else they got for us here. Blah, blah, blah. Ooh, here. Ooh, look at this big beast of a thing. Yuck. So let me write this a little bit differently. So what's unfortunate, what I really, really hate, is that we actually don't know enough math for me to prove that to you. If anyone wanted to see the proof, I could give it to you, but we don't. There's certain processes that we don't even know how to do. So in that they're required for me to prove that that's true. But do you remember? So you remember the whole idea behind the vertex? Does anyone remember how we got to this? What did we start with? So if I had a parabola and I know these x-intercepts, where must the vertex be? I mean, just, all right. So this is 2 and this is, let me say that. Let me give us some numbers. Sorry?
So it would be at in the middle of that. So what would that be?
Middle of 2 and 4.
So 0 and 3.
So I'm just 3. Be careful. I don't know. I'd have to know what the function is and plug it in to see what this output is, right? But I know that the x piece is 3. That's what led to this. And again, if you watch yesterday's video, you can see the proof of where this thing came from. It came from basically starting here. If I know the intercepts, I know the vertex must be right in the middle of them. Now, stay with me, stay with me. Isn't this the same distance from here as it is to there? Isn't that kind of dumb for me to say? How did we get 3? Because it's in the middle. Won't it be the same distance to either side if I'm in the freaking middle? Isn't that just obvious? Yes. If I'm in the middle, I'm the same distance from both sides. You with me? So in fact, in this case, Isn't it 3 plus 1 to get to here? And isn't it 3 minus 1 to get to there? All right, I know this is deep, but all right, I love you guys. So the leap we're going to have to take, which is unfortunate, is this. This is negative b over 2a. Does everyone agree with me? Isn't that how we would get it? If I had the function to get 3, I would do this, correct? In fact, let me make the function up. You ready? Am I ready? All right, this is the function. This is my parabola. I just gave you the function. So how would I verify what I just said? I don't know if you guys are with me. I'm throwing a lot of different things at you. But this is one possible function for the parabola I drew. When I do negative 6 over twice 1 is 6 over 2 is 3. Yay! Okay. Now, so there's always some amount that I add and some amount that I subtract to get out to the intercepts. Does that make sense? If I know the middle, then there's some constant amount that I would add to that and subtract from it to get to the intercepts, because it's in the middle of the two things, of course, right? So is there a formula that can figure out how far that is from either side? Yes, there is. There's a formula. Is it pretty to look at? No, it isn't. So look at this. Does everybody understand this? This is the middle, and I go up and down by some amount to get to the intercepts that are in between. Is everybody cool with that? That idea? So here's where that 1 would come from. Here's the plus, here's the formula. You ready? This is the formula I can't really prove because we don't know enough math. But maybe somebody sees that. I mean, look at that. Isn't that beautiful? You guys don't have to say yes. It's okay. It's gross. This is what gets me that. Let's check it. And again, I think only a few of you guys said that you'd ever seen this before. And I've written it a little different than what it really looks like, but we'll write it the conventional way in a minute. All right, so everybody agree with me? For this function, we already showed that this is 3, correct? Right, you guys with me? X equals negative b over 2a is 3 for this function. So let's figure out what the hell this piece is. So help me out. What is b in the function I've got? What is b?
Negative 6.
And what's negative 6 squared?
36.
36. I like it. So 36. Why did I make this so big? I don't know, Jeff. Minus 4 times a. What's a?
1.
1. Please let me know if you don't see where this is coming from. Somebody else tell me what c is.
8.
8. I love it. Divided by twice a, which again is 1. All right, stay with me. Oh, some of you guys are tuning out now. You're like, so much shit in there, Jeff. It's just shit. Don't let it get to you. Of course, I don't know how to use my space correctly, but too bad for everybody. So what are we getting here? We get, what's 4 times 1 times 8?
32.
Yes. And what is, let me bring this over here. Dadgummit, sorry, everybody. Hopefully you guys can keep up here. What is 36 minus 32?
4.
4. And what is the square root of 4?
2.
2. And what's 2 divided by 2? 1. And isn't that what that shit? Holy shit. Holy shit. Isn't that what it is? Isn't that what it is? All right. So we didn't just prove anything, but I did show that this does give me the correct amount to go up and down. There's a lot going on here, and I'm sorry. So let's try another problem, okay? Let's try one more problem, kind of the way I'm doing it, and then I'll show you the full formula without my little changes. Okay, so, all right, good Lord, I've really got to work on, God, this looks weird. I don't know why I think of Rocky Horror Picture. I see like lips here. All right. Let me-
Professor,
yes.
I have a question. On the here. I didn't understand about 4 and 2.
Oh, okay. I'm glad you're saying that. Can somebody help me factor this?
Oh, understand.
No, yeah, help me out. Help me factor this.
It's gonna be 2, -4.
Well, -2 and -4, right?
Oh yeah, -2 and negative.
So wouldn't that lead to a 0 of 2? Then a 0 of 4? Do you guys see that?
Yeah.
So I actually created this equation after I drew this parabola because I knew that this would lead me to these numbers.
Yeah, I didn't understand where they come from.
I understand.
Understand.
All right, so I'm going to clear all this. You ready? Here we go.
Yeah.
Now, let's do this. All right, so let me give us, give me a second. Let me think. Let me give us something that's not too crazy. You can do it, Jeff. Can you? I think I can. There it is, buddy. You've done it. Good job. Now, let's do this. Stay with me. All right. Let's figure out the vertex, right? Help me figure out the vertex. What is B?
-12.
-12. And what's A?
1.
1.
1.
So I get 12 over 2. I get 6. All right. Now how do I get the Y piece? Of course, I'm just going to plug it. Let me give this thing a name. Sorry, guys. Hold on. So I'm going to put a 6 in. Let me do this a little bit quickly. 6 squared is 36. 12 times 6 is 72. And I end up with -1. So you guys can double check me on that if you want to. So somebody tell me what the vertex is.
6 -1.
6 -1. All right. Now, let's figure out what the x-intercepts are with this new funky ass thing we've developed here. We didn't develop it. You're just taking my word for it, but you know. And again, this looks ugly. Does anybody agree with me that this looks ugly?
Yes.
Get past it looking ugly. Isn't it just plugging in B and A and C and doing the shit it says to do? Isn't that all it is? So it might look ugly. That doesn't mean that it's hard or a lot of work. It just looks ugly. Poor little thing. It doesn't want to look the way it does. Poor little thing. So we already know what this is, right? We figured that out. That's 6 plus or minus. All right, help me fill all this stuff in. What's B again? B was -12, right? What's -12 squared?
$144.
144 minus 4 times A times C. Ooh, that looks yummy. Divided by twice A. So all I did was plug, and again, if you have to, you can actually just take a minute. A is 1, B is -12, Jeff, C is 35. So then you can just plug all the numbers into the right place, right?
Yes.
So this is 6 plus or minus. What do we get under the square root? We get 4 times 35 is 140, right?
Yes.
And 144 minus 140 is 4. So you get 6 plus or minus 2 over 2. 6 plus or minus 1 is 5 and 7. Oh shit, so what does that mean? All right, I love you guys. Stay with me now. What does that mean? That means those are the x-intercepts. Because remember, where's the vertex supposed to be? It's supposed to be in between the x-intercepts. So that's what this equation does. This equation finds the x-intercepts. Now, could somebody factor this for me?
-7 and 5.
Yeah, both negative, right?
And yeah.
So wouldn't this lead to x equals 7 and x equals 5 as the intercept, as the what makes it 0, correct? Do you guys see that? Isn't that what makes it 0? No, yes, no, remember that? What makes this 0 would be 7 makes that 0 and 5 makes that 0. So that's what makes the function 0. And that's what the intercepts
Yes.
are. Okay. So some of you guys might say, appropriately enough, somebody must be thinking this. Why would I do all this shit when I could just do this? Is anyone thinking that? Why would we do all this shit when I could just do this? Yes? I would hope somebody's thinking that. No? Was this hard to do this? To find these two numbers? Factor it and then look at it? Was that
No,
hard?
not really.
Was this hard? I got the same numbers here, right?
Yeah.
Was this worse?
No, I mean, once you get through like it's just
Yeah, this isn't
basic
bad.
math. No.
This isn't bad. But even I, math lover that I am, would admit that this is worse than that.
Yeah.
Okay. So what's the point? Well, the point is this method works even if this shit ain't factorable. Right? Now I'm picking ones that are factorable just so we can easily check. But even if this was not factorable, this method right here still works. That's the power of it. So if it's factorable, am I ever going to do this? Hell no. Hell no. If this is factorable, I can just do this. Why would I ever do this shit? But if that's not factorable, I have to do this. I really want you guys to understand why this exists. All right, let me clear this away. Okay, I got a chat. What's happening? Got me. Okay, I like that. Let me clear this away. I'm going to clear it away. And let's see what the book says. Come on, book. Catch up to us, buddy. So the solutions to a quadratic equation, and oh my God. So the better way to say this is the x-intercepts for this function are given by this. So remember, this is basically what we just did. They just kind of put them together because they're both over 2a. So this is the good old quadratic formula. I think it was it Caitlin that you had the song that she sang for us? I'm not asking you to do it again, don't worry.
No, it wasn't me. It was somebody
It wasn't you. There was somebody that sang the song. Nobody wants to fess up to it. Okay, I don't know why I thought it was you.
I confess, yeah, that was me.
Oh, Sabrina. Okay. All right. So yeah, there is a little song. All right, don't worry about it. Okay. Let me see. Blah 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 blah. Now here we go. Let's get some neat shit. Oh, see, they're catching up to me. I forgot they did this. They basically do exactly what I did. Do you see here, right here? Aren't these the two things that we did? I don't know if you guys remember.
Yes. Yes.
Yep.
Yeah, so I kind of did all this backwards because it makes more sense the other way. Blah, 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 blah. They're finally catching up to some stuff we did. Oh, all right. So here is the function for somebody's home run that they hit. They hit a home run. Now think about it. Has anyone ever played baseball, watched baseball, knows what the words baseball means? Anybody?
Yep.
All right. When you hit a baseball, what shape would the flight of the baseball create?
A parabola.
Parabola. Now, ignoring air resistance. Now, to be honest, you can actually build air resistance into the formula itself, and it's normally this part of it right here. That's why this is such a funky ass number. It's because they built in the air resistance to this piece. Ooh, we don't have to get that deep. I'm sorry. Now, are these numbers yummy? Would anybody?
Yeah.
I know you're like, I wouldn't call any number yummy, Jeff. All right, that's you and your weird shit. Does that make this harder? No. How do I find the vertex? What's the shortcut? What's the formula to find the vertex? Anybody? What's the formula to find the vertex?
Negative b over 2a.
Yeah, so I'm just drawing a little dude with a little bat and he hits the ball and it goes like this, and somebody in the stands gets hit on the head with the ball because they weren't paying attention. Everybody's screaming. I was like, what do you guys want? Pop. Oh, all right. Sorry. So negative b over 2a. So I know the numbers are gross, but who cares? What's b? What's b?
0.718.
Beautiful. And what's a?
Negative 0.0014x
146.
squared. Yeah. Just
Yeah,
that.
it's only the coefficients. I like it.
I think I meant to say 6, but it came out x.
I understand. So throw that in your old calculators. Let's see what we get. I'll do it too. Let's see if we get the same thing. You got to be a little careful how you put the bottom in. You got to make sure you divide by everything you're supposed to divide by. Let's see what we get. So they tell us earlier that x is time in seconds, y is height in feet. Does anyone get an answer for this? You just got to plug that in the old calculator. What's happening up there? Now, when you put it in the calculator, if you do this, you got to divide by 2 and negative 0.0014 because they're both on the bottom, correct? Divide by 2 and divide by 0.00146. Does anyone get an answer for that? Just so you feel better about whatever number you're getting, it's supposed to be 200 something.
Minus 245.
No,
Point.
plus 245.9, right?
I get it wrong.
Because the two negatives cancel. You left out one of the negatives. So that means, what does that mean? Where is this on the picture that I drew? This beautiful picture. Where is this on this picture? What did we just find? Sorry.
In the middle.
Yes. So in the middle. 245.9. I guess that's seconds. This doesn't make any sense to me now. Wait a minute. 0.718, 0.00. That can't be seconds. What have they done to this poor formula? Is that seconds or milliseconds? All right, guys, hold on. I got to see what they did with this. I'm kind of assuming what their variables are. All right. No, where they got this formula? I'm sorry, guys, hold on. Where do they have this formula? This is the first place we learn about this formula? Ah, that's such a weird answer. All right, I'm freaking out about this. What is going on here? Sorry, guys, hold on. I don't know. It doesn't make sense to me. So there's no way it takes 245 seconds. This must be milliseconds. They don't ever tell me what X is. I guessed it was seconds, but I don't know. This kind of sucks. What's the output? I don't like this problem they created. So this is X. How do I figure out what Y is?
2.5.
How'd you do it? What'd you do?
Oh, sorry. The 2.5 is the Y.
No. What's happening? No. Not the Y-intercept. I want to know what the vertex is. So I know X is this. Now I want to know what Y is.
Okay, we have to put the 245.9 instead X. Okay.
Yes, good. That is so exceptionally weird to me. I'm really sorry, guys. I think they made a horrible example.
Professor, I have a question.
Yes.
In the first line, when you make it to put it in the calculator. You said minus 0.718
Oh, I see.
divided by 2 divided by is not times here.
Of
Second
course,
one.
it's not times.
Why?
Am I
Because
multiplying by this? No. Aren't I dividing by that?
oh, you put
Another
it-
way you could do this, if you wanted to, is you could divide, put a parenthesis here, and then put a times here.
okay.
You got to be really careful. And now I understand what's going on here. So let me explain. I don't see anywhere they say this. So you could make this a times, right? If you want to do that, you could put
Okay.
this, because the calculator doesn't know that that's all on the bottom.
Okay.
So if you put 0.718 divided by 2 times this, it's going to take this up top. That's not where it is.
Mhm.
Yeah. Now, the reason this makes sense is because X is not time in seconds. This is my mistake. And I don't see somewhere they tell us in this book what this formula is. X is feet horizontally. Y is height. So 245 or almost 246 feet there is where it hits its highest point. All right. So X is not time. I've been doing that wrong my entire life. Oh, shit. True. Maybe. So Y, I get 90.8 if I round it feet. So this is how high it gets in the air, is 90.8 feet, and it gets 246 feet almost out is where it hits its highest point. All right, that makes more sense. I thought X was time, but X is obviously distance. That's my mistake. I do want to, what was it I wanted to say? Shit. Oh, real quick, a word about this. So this here, if you put in your calculator this, if you put this in your calculator, negative 0.00146, that would effectively be this, set 0.718 divided by 2 times negative 0.00. This is what I meant. So it actually puts it up top if you do this. So you either have to put this in parentheses, or you have to make it 718 is divided by 2, and it's divided by negative 0.00146. Okay. Oh boy, that got technical for a minute. But again, your calculator's dumb. Your calculator's dumb. It is dumb as shit. Why? It don't have brains. It don't know shit. What are you going to do to me? Oh shit, you're going to do something to me. It's dumb. So we have to know how to put stuff in, because it takes everything we put in literally, right? Literally. I'm using that word correctly. Okay. For once, let me see here. I have no idea if you guys are with me at all, but so X is the distance horizontally. So when does it hit its highest point? 246 feet away from the home plate. How high does it get? The highest point, 90.8 feet. Voila, good. I'm going to clear all this away. Here we go. What time is it, by the way? Oh, okay, we got blah, 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 blah. Here we go. Okay, well, let's do one last thing here. Okay. Okay, here we go. The price. Oh, God. Sorry, guys. The bath beads. All right. So we did all this before. Here's the profit function. I don't blame you if you don't remember this, but this was the profit function. Do you remember this thing about the bath beads? You guys remember that problem when we're selling jars of bath beads? Remember that? And somebody said they were bath salts, and that's an entirely. Be careful, kids. Don't do the bath salts. Blah, blah, blah. So let's analyze. If I found this guy's vertex, what would be special about that point in this situation? What would be special about the vertex in this situation? What is this function again?
What? The profit function was
Profit function.
Yeah.
So if I find the vertex of this, how is that special for my business?
Is that when you're making the most money?
That's when you're making the most money. Kick ass, because this is a down parabola, correct? So the vertex will be the highest point. So I want to know when that is. And X, they don't tell me here, but X represents the number of jars to sell. Remember that? So wouldn't you like to know how many jars it would take to make and sell to make the most money? Isn't that something you would want to know as the business owner? Would you be a little curious about that? Or are you just like, whatever happens, happens, man. Selling my mystical bath beads. I'm okay with the university. No, I want to know. Shit. So find this guy's vertex. Go ahead. Do it. Find the vertex of the profit function. All right, I'm going to start to catch up to you guys. You do this in your head, Jeff. Why not? Let's see. Bam, 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 bam. 37. Is it 370? Let me see. I don't trust myself this morning. Whoa. Oh. That's interesting. Hey. Nobody got that yet? So remember, when you put it in, I would highly recommend you do this. Right? Because what am I doing to this? I'm dividing by 2 and I'm dividing it by 0.025. Does anyone have that answer yet? You guys doing okay out there?
Sorry, Professor, what was that?
Do you have the answer?
No.
370?
Yeah, 370. All right, so take a minute. Make sure you can get 370. Let me know if you can't get 370 from that.
I know how to do it, but I'm just in my car, so I don't have my calculator.
Oh, you're
I'm
fine.
trying to shot it and then like write with that little pen on
Oh,
my
yeah.
phone. Like
You're fine. Don't worry.
but I understand.
Okay. So what does that mean? What does this answer mean physically for me as owner of this business?
It means that you're still having profit, right? At this point.
I understand.
So
remember what everybody say, finding the vertex is a good thing because this is a down parabola and the vertex represents the what?
the highest.
Highest profit.
Yeah.
Now we figured out the X piece of that. X is the number of items to sell. So what does this mean?
So the number of items to sell is 370 items.
I sell and make 370 jars of beads. I'll make the most profit possible.
Yeah.
Yes. Isn't that good to know? So
Yeah.
if I'm like selling 40 jars a day, I'm like, well, I gotta do something. I'm not being optimal here. I might even be losing money if I'm only selling 40 jars. So now the question is, what would the profit be? I know this makes the maximum profit. Do you think it's possible for a company's maximum profit to be negative?
Yes.
Yes, unfortunately, yes. You could have a look at this profit function. Isn't it the maximum? Isn't that the highest point? Isn't it negative? That would mean you need an entire business model reorg, right? And that's the most business I ever want to discuss. But obviously, if your entire profit function is down here, that's what happened to .com companies in the 90s. I don't know. Not really. That definitely oversimplifies it, but I thought it was funny. Some of you guys are like, 90s? All right. How do I figure out what the profit would be for 370 jars of beads sold? You guys know what to do. How do I figure it out? Isn't this what X is? So all I'm asking you is, how do I figure out what the profit is? What would I do?
We're gonna find the Y.
Yeah, so I'm just going to take this and I'm going to plug it in. All right, let's see if we can do that. And this will be the last thing we do today. Plug a 370 in here. Let's see what we get. Not bad. So what do you guys get for the profit? That's so helpful, Jeff. Thank you for that. Sorry. Anybody? I know some of you guys are calculatorless at the moment. That's fine.
6184.
Well, let's see. Did I put it in there right? It's not what I got. Yeah, I put it in there right. That's not what I got. I got 3,000 something.
I got 3,097.
Yeah.
Oh, wow, I was right.
Don't forget my 50 cents. So we make almost $3,100 profit. I can't remember if this is weekly or what this is, but I mean, nowadays any positive profit is good. So do you understand what we just did was not any different than what we were doing earlier with the functions with nicer numbers? I found the vertex. All right, the numbers are gross. I don't care. The process doesn't give a shit. Still negative b over 2a, and then you plug what you get in to figure out the output, which in this case means profit. It's kind of neat. So math says if you can set up an equation to model a situation, you can then analyze the equation to figure out what to do about the situation. Isn't that interesting? That's a huge part. That's like meteorology. What I just said is meteorology. Right? You have equations that model weather conditions that would tell you where a hurricane is going to go. You analyze the equations to tell what to do, to tell who to warn, to tell who to evacuate, all that kind of stuff. Okay, all right. If there's no questions about that, that's it. And we're basically done for the semester, guys. Tomorrow and Thursday, we're going to review for the final. All right. And we're not going to learn any new shit. That's done. I'm sorry. I just screamed at you. We're not going to learn any new shit. This is the last new shit we had to learn. That was the new shit. All right. I'm going to stop sharing, see if anybody screams at me. Let's see. Does everybody understand? You can go now if you like. You can let me know if you need to hang out.
Thank you so much, Professor.
Thank you so much.
All right. See you tomorrow.
Thank you, Professor.
All right, guys.
But
See y'all tomorrow. Is everybody good? Anybody need to anything? Okay, I'm gonna head out. See you later.